And we are live.
Okay. Welcome everyone to the second OLOFOS seminar of the year. Today we have the pleasure to have Alexandre Francq from Université Paris Panthéon-Sorbonne, who will talk about
You're live. Okay.
Welcome everyone to the second OLOFOS seminar of the year. Today we have the pleasure to have Alexandre Francq from Université Paris Panthéon-Sorbonne, who will talk about the haunting specter of complexity, the pluralist metaphysical crutch. The floor is yours.
Thank you so much, Victoria, for the introduction. So first of all, I'm really glad to be back in Belgium, and especially here in Louvain-la-Neuve. It's the first time I come. So thank you for everyone for being here and for the organization committee. So the subject of my presentation today will be about the relationship between the concept of complexity in science and its implication for philosophy. In particular, I'm going to study the role that the concept of complexity plays in both science and in the pluralist philosophy of science. So the first point is that appeals to complexity are everywhere, both in science and philosophy. In science, they have a double role. They are both explanandum and explanans. As a scientific explanandum, we want to know what complexity is and how to measure it. It is the object of many science, including system biology and complex system biology. As a scientific explanans, the fact that a system is complex is often used in the literature to explain some properties of the systems or to predict some property of a system. And as a philosophical element, it is used to justify or to ground certain philosophical arguments, mainly in these forms that the complexity of an object means that a particular philosophical thesis is wrong, or that a particular thesis is true. Think, for example, about reductionism, pluralism, emergence, and stuff like this. So complexity is used in a different way. I want to specify what I mean by used as an explanandum, explanans, and a justification. I've used scientific extract from cancerology because it's my field, but you can find examples in many disciplines. For example, in cancer, you have the idea that you have to understand complexity of cancer. You have to understand in which sense cancer is complex in order to better treat patients. You also have the idea that once you ascribe complexity to cancer, you then ask a particular set of questions. For example, what are the components of the systems? What are the connections between the components, the state of the component and the system as a whole? There are also other questions. But it's also used as an explanans, meaning that it's used to explain and predict properties. For example, in the first paper by Malik in 2016, you find the idea that we found that biology in general and cancer in particular can be viewed very naturally as a complex adaptative system. By altering our perception of cancer, we may gain a deeper understanding of the disease, uncovering new ways to prevent it, diagnose it, and treat it. There you have the idea that treating something as complex may open ways to study it. It may explain why some strategies might fail and what might succeed. It also can be used to predict particular outcomes in regard to application of models. For example, in a review of mathematical models of cancer dormancy, you find the idea that typical interaction between cancer and immune cells are more complex than Lotka-Volterra models typically allow. So this is for complexity as an explanans. In philosophy, you can find complexity both in conclusion of arguments and in premises of arguments. For example, in The Fate of Knowledge by Longino in 2001, you find that philosophers who advocate strong form of pluralism are claiming that the complexity of the natural entities and processes eludes complete representation by any single theoretical or investigative approach. In Mitchell, who is also a strong defendant of complexity, and we will see that later, you find the idea that complexity is everywhere and that the challenge of natural complexity has been clear since the writing of the earliest scientists, the history of science for Michel has in large part been shaped by efforts to explain and predict in the face of complexity. So as you can see, it's everywhere, but it's rarely defined. And the first hypothesis I want to study is whether complexity is merely a synonym for difficulty. That is, when we speak about difficulty, about complexity, do we just mean that something is difficult to study? I think there is elements in that direction, but really that depends on the case. I propose a distinction between something being easy or difficult and something being simple or complex. For me, difficulty is a property of a relationship involving the capacities of an agent and a situation. Something is easy or difficult because I have some capacity and I have a problem. For example, understanding the rules of football is difficult for me, but it might not be for you. Complexity is the opposite of simplicity, and complexity seems to be used as a more or less intrinsic property of something, whether a relation, a mechanism, a situation, or an object. For example, cancer might be complex whether or not super intelligent people are investigating it. A more logical question is, could we imagine that a complex system might actually be easy to study for super intelligence like an AI or stuff like this? My idea is that in most empirical cases, most complex systems might be difficult to study. But from the fact that something is difficult, one cannot deduce that it is complex, for there are things that are difficult but not complex. And complexity is not always a mere intersubjective difficulty. So complexity is not purely subjective, but it's not purely objective neither. For the recognition that something is complex might depend upon subjective matters, such as epistemic interests and the objects, the tools that we develop to answer the scientific question we have. For example, if you want to study an anthill, well, it is very complex to describe the dynamics of an anthill at a microscopic scale or even an individual scale. And if you want to describe the dynamics of and the behavior of each ant separately. But at the scale of the universe, it's really easy to describe what an anthill will do. It will appear and it will disappear. And it also depends upon, so it depends upon what questions are we asking to a system. And it also depends upon characteristic features of the models and the theories we use to describe those complex systems. And in the scientific literature, it's not always clear that what we call complex is the object itself or the model that we use to mathematically describe the object. For example, in most accounts of complexity, you found that one property of complexity is nonlinearity. But strictly speaking, nonlinearity is not the property of something. It's not the property of a concrete object. It's a mathematical property of an equation. So sometimes it's not clear whether the system is purportedly complex or it is the model that we use. So what I want to say is that complexity is not purely subjective. It is not simply a matter of difficulty, but it's not also purely objective. It's not like solidity, for example. So the problem is to know how we can define complexity while both accounting for its intrinsic yet subjective components. And I will also try to show why that matters for philosophers and scientists. So what are we searching for? Classically, a philosophical definition in the Platonic or Russellian sense identify essential properties that make a concept distinct from others. That is, the necessary and sufficient characteristics that determine its application. For example, a triangle has 3 sides. That's a necessary and sufficient condition for something to be a triangle. The first question is whether or not such a definition of complexity can even be possible. Can we have a statement in the form something is complex if and only if X, Y, Z? Why does it matter? It matters because if in philosophy we are to justify arguments or ground philosophical theses like pluralism or anti-reductionism on the concept of complexity, we have to make sure that we are indeed speaking about the same thing. And even if we disagree, we have to be clear about what we are exactly disagreeing about when we say that something is complex or not complex. And in science, for complexity to play an explanatory and predictive role, complexity must be active. That means it must add genuine epistemic or philosophical value to qualify something as complex. Otherwise, complexity risks to be vacuous. An example of this is in Molière's Malade imaginaire. You have one student is asked what makes sleep when you take opium, and he responds that there is a dormitive virtue to opium, which is a property that makes people sleep. Well, in that case, it is circular, but what interests us really is that it is vacuous. It means nothing to say that opium has a dormitive virtue. And my concern with complexity is exactly this. Is it vacuous to say something about something that it is complex? So here's the general outline of the arguments I'm going to propose here today. So most of these arguments are relatively new, so that's why I want to have feedbacks on them, to know how far we can push them really. My first argument is that whether one is a realist or a pragmatist about complexity, there might be no necessary and sufficient conditions to complexity. That's my first argument. My second argument is that if you want to abstain from metaphysically characterizing complexity, Wittgenstein's concept of family resemblance might be a good candidate to describe how complexity is used. And the third argument is that we have good reason to abstain from metaphysically characterizing complexity, at least in certain contexts and under a certain sense of what we mean by metaphysics. So I now start on the first argument. And for that, I draw on a recent book by Ladyman and Weissner, which is called What is a Complex System?, which tries to give a broad overview of the different ways in which the term complexity is used in science, how we measure complexity, which is really important, and some philosophical background on the notion of complexity. Their main argument is that complexity is basically this kind of cluster of property. They distinguish between features of complexity and conditions of complexity. Conditions of complexity are things that are part of complexity as we use the term, but that enable particular features. So these conditions are numerosity, diversity, disorder, a non-equilibrium state. All these conditions for them enable particular features that you can observe in physical systems or biological systems, such as an adaptive behavior, memory, functional redundance, modularity, and stuff like that. So they identify a cluster of properties, and they actually defend the thesis that there is no essential property to complexity. Yet, of course, it's Ladyman and Weissner, so they want to argue for a realist conception of complexity. They argue that complexity is not an empty label because it picks out real properties, and they even consider that it can be what we call a natural kind, like gold or some atoms. They oppose the realist conception to a pragmatist conception. They just tell that the pragmatist conception is basically to say that complexity is useful to scientists, whether or not it actually picks a natural kind. But they really don't detail this position. They just say that they won't accept it, but they don't tell why. And this is what I'm going to do. I'm going to ask myself, what could be a pragmatist conception of complexity? And one has recently been proposed, at least sketched by Anya Plutinsky in 2001 in a paper that interested me because it was on complexity in cancerology specifically. And the interesting thing is that she does the same thing as Ladyman and Weissner, which is she look at scientific papers and she look at ways in which scientists identify complexity and measure it. And she identifies more or less the same properties. And she has the same conclusion as Ladyman and Weissner. She said that complexity is a multifaceted phenomena that resist essential definition, that means by necessary and sufficient conditions. Yet from the same conclusion, she argues against considering complexity as a natural kind. From basically this argument, she says that for something to be a natural kind, it must possess at least one property P, such that all tokens of that kind share P. That is a necessary and sufficient condition. that tokens of complexity in cancer research do not share such an essential property, and that complexity in cancer research is not a natural kind. What I want to do is not put myself in the debate over natural kind, because it's a very spiky debate. But what I want to show for the sake of my argument is that whether or not you are pragmatist or realist, you agree that there is no essential properties to complexity. Because at least the way I understand it, without being a metaphysician myself, is that the disagreement over whether complexity is a natural kind is not about the existence of essential properties of complexity. Because no matter what you are, you agree basically that the absence of essential properties disqualify, the disagreement is about whether the absence of essential properties disqualify complexity from being a natural kind. So that's the debate between the classic conception of natural kind by Yana King and stuff, and the homeostatic property cluster by Alexander Boyle. So there seems to be an argument from both sides that complexity cannot be defined by essential properties. That's my main argument. Complexity designates a cluster of heterogeneous properties, none of which are necessary nor sufficient for something to be considered a complex system. So that's for my first point. The second point is that I'm going to try to give a more defined account of the pragmatist conception of complexity that Lutinsky sketched. And for that, I'm going to use what she suggests, which is that maybe the concept of family resemblance in Wittgenstein might be a good idea. So I said that complexity is a cluster of properties. And can we make sense of that without making complexity just an empty label? That's more or less my question. And Lutinsky says that complexity might be better understood as a family resemblance concept rather than a natural kind. Yet she doesn't pursue this suggestion or consider what it would mean really for philosophy and science to consider complexity as such. So second question I ask is whether that concept of family resemblance describes how complexity is used and what it designates, and what really are the implications for science and philosophy. So if you go back to Wittgenstein, I'm going to read that little excerpt from the philosophical investigations. I forgot to quote the little reference. He says that at the moment he's speaking about how to define a game, because he has this concept of language game, and said that people might object to him that he did not define what is a language nor what is a game. And so he said that when we look at concepts such as games or language, we see a complicated network of similarities, overlapping and crisscrossing, sometimes overall similarities, sometimes similarities of detail. I can think of no better expression to characterize these similarities than family resemblance. For the various resemblance between members of the family, build, features, color of eyes, gait, temperament, etc., overlap and crisscross in the same way. So the idea is that in the same way that I have the eyes of my mother and my sister eyes as the nose of my father, yet we are both in the same family, but we do not share a necessary and sufficient condition for being in that family. In the same way that if you adopt someone where he will have no physical features or genetic code that makes him a part of a family, yet he belongs to a family, and you can have members of the family that do not share the same name, for example. So that's the idea from Wittgenstein. In an article about the concept of species, Pigliucci made a nice figure to show this. Basically, you have, like he said, clusters of properties. You have the general category of games, and there are board games, card games, ball games, games with rules, games without rules, game where you can win and not win. But none of what we call games in our language share an essential property. So that's the idea of family resemblance. So why does it matter really to reframe the question of complexity as a family resemblance? It might be that it can support the argument that a concept can be scientifically useful even though it does not capture as an essence, which is exactly what Ladyman and Weisner call the pragmatist conception. Just as we use a computer without knowing the sharp boundaries between what is a computer and what is not, we can use the concept of complexity in that same way. So it redirects the focus from trying to identify what is complexity to when the system is complex and how does the different features of complexity interact with each other. But, and this, Plutinsky does not speak about this, I think that characterizing complexity as a family resemblance concept has at least two important consequences for science and philosophy about how we think about complexity. The first consequence is about what we count as complexity or not. Because an objection might be to say that, well, since the cluster of property, does it mean that anything can go with regard to complexity? Can anything be complex? Well, that's not evident because saying that something is a family resemblance does not mean that anything can belong in the family. From the fact that something does not have any sharp boundaries, we cannot immediately conclude that some boundaries can't be drawn. So here is what Wittgenstein says about it. How we should explain to someone what a game is. I imagine that we should describe games to him, and we might add, well, this is a similar thing. All these similar things are called games. And do we know any more about it ourselves? It is only other people whom we cannot tell exactly what a game is. But this is not ignorance. We do not know the boundaries because none have been drawn. To repeat, we can draw a boundary for a special purpose, but does it take that to make the concept usable? Not at all. So that's the first consequence, is that it is not because something is a family resemblance that anything can be counted as complexity. But the second problem is how to understand the concept of boundaries that Wittgenstein speaks about. And for this, there is an important philosophical lesson, I think, is that if you take, for example, chess, well, chess is a game, but recently it was refused from the Paris Olympics. And the reason that the Olympic Committee said was that for them, a game required physical exertion. It requires to move, basically. But what Wittgenstein will say is that this is not the essential definition of what a game is. It's just that in that context, we needed a boundary to restrict what games we will use. And in that specific context, physical exertion is one of the boundaries we can draw. And whether or not it's a good boundaries will depend upon what our interest is. And about the resemblance between chess and the other games that are in the Olympic Games. So if we accept that family resemblance, that complexity is a family resemblance, it is possible to propose provisional and contextual definition of complexity. However, this definition will only be valid in particular contexts and will have to be justified within those contexts. Accepting complexity as a family resemblance implies, and this is important for philosophers, that we need to stop looking for the correct, true account of complexity. And the second consequence is on the role of paradigmatic cases in family resemblance. This has been shown by Michael Simon in '69. It shows that basically, as in within the family, they are members of the family, and some of them are really important, and some of them are outliers. He says that basically, when you have something that is a family resemblance, not every member of the family is as important as the others. Some are more important, and this is what we call paradigmatic cases. These are cases that are used to exemplify what is the category, and it shapes how we think about other members in the family. For example, chess is a perfect example of a mental game. Football is a very good example of a cooperative game, and track and field is a very good example of an individual competition. When we think about including a new activity as a game, Simon says, we cannot use an essential definition because we don't have one. So what we use is a form of resemblance thinking. He says that, for example, if we ask whether throwing a ball against a wall is a game, we look at other games. We say, well, is it like chess? No, it's not, because it's not a mental thing. Is it like football? Yes, because there is a ball, but it's not cooperative, such and such. I think the same argument might be useful in the case of complexity, because you have those paradigmatic cases For example, one of the first cases you're going to look at is the ecosystems are paradigmatic cases of robustness, because a forest can burn and 3 months later be in the perfect. Organisms are perfect examples of non-equilibrium dynamics. They are always exchanging materials with the environment and stuff. So the important lesson here is that maybe by looking, instead of searching definitions, we might need to look more closely at what are the paradigmatic cases of complexity and how they shape about what we think about other cases and new cases of potential complexity. So what we have seen so far is that, as I showed earlier, complexity is a cluster of heterogeneous properties, none of which are necessary nor sufficient. Conceiving complexity as a family resemblance concept might allow us to grasp its scientific value without relying on rigid definition or sharp boundaries. Any attempt to draw a boundary may be valid within a scientific context, but no single definition can capture a presupposed essence of complexity, and we can identify paradigmatic cases of complexity and examine how they shape our understanding of the concept. A possible objection so far about, I think, this pragmatic approach to complexity, and I try to imagine what Lady Mark would say, I do not know it, but that would be that if we want to use complexity to ground philosophical theses, to justify arguments, or to explain and predict scientific results, would it not be better or more fruitful to adopt a strong metaphysical interpretation of complexity? That is basically that complexity is really an intrinsic property of a system themselves, rather than a mere useful way of speaking about certain cluster of properties that may be contingently linked. My answer, as before, it is that it depends. Because in some instances, I think that we have good reason to think that metaphysical interpretations of complexity or related concepts may do more harm than good for philosophy and in science. And for that, I'm going to briefly address a case study in the work of Sandra Mitchell, which is integrative pluralism. So basically pluralism, as Mitchell conceived it, is the answer to a particular question, and the question is this one: how can a diverse, well-confirmed, but irreducible set of theories be used collectively to achieve a more complete understanding than any of the theories taken in isolation? Depending on your tradition, pluralism might either be the opposite of monism or the opposite of reductionism. If you want, like, place to know where you are. And in her thesis, she makes a big role for metaphysics. She basically asserts that scientific pluralism can be grounded, and she used the term grounding, the verb grounding. Scientific pluralism can be grounded on a metaphysical interpretation of complexity, and that for her, pluralism simply reflects complexity. And the last part is really important. The way the world is, this dictates what we can say about it. So in what sense is complexity a metaphysical predicate for Mitchell? Well, in the book, she characterizes 3 senses in which complexity is present in biological system. You have constitutive complexity, basically the idea that stuff have parts. Dynamic complexity, which is the idea that in organism you have nonlinear dynamics, feedbacks, stuff like this. And evolutive complexity, which is the idea that there is a lot of diversity in nature because natural selection is irreversible, so you have a lot of outcomes to a single problem. Those categories I won't cover much because they partially covers what we have seen before with Ladyman and Weissner. But what these 3 notions share is an appeal to ontological structure. They describe for Mitchell how the world is rather than how we model it. Because Mitchell need to do this because her thesis is precisely that there is a gap between the simplifying and the reductive nature of our representations and the intrinsic complexity of nature. So here, complexity is doing basically the justificative labor, it's doing the ice cutting. So to study the implication of this metaphysical charge, as I call it, and to study whether or not it can be verified, I took a framework proposed by Stéphanie Roussy, which herself draws it from Ernst Nagel in '61 on the debates of emergence and the reduction of physics and chemistry. And she proposes that, well, Nagel proposed that metaphysical statements can either be temporally qualified or generally valid. A temporally qualified statement is indexed to a theory. It takes the form according to theory T, system S as property P, while a generally valid statement is just S as P. On a temporally qualified statement, the truth of the proposition depends upon what the theory says. Whether in a generally valid statement, the truth of the proposition does not rely particularly on the specific theory. And the proposition in a temporally qualified statement depends on the current epistemic context, while on a generally valid side, it should be verified by an extra theoretic proof, which cannot be given if we accept theory validness. That's exactly the point of Nagel. Nagel said that no metaphysical statement can be generally valid because for that, you will need to step outside the theory and you cannot. So that's the point of the distinction. So here is Nagel and Roussy's cautionary tale, mainly Roussy's one. She says that philosophical questionings of local scientific methodologies, when based on empirical considerations, are undoubtedly valuable for scientists, but they are much less valuable when based on metaphysical contentions. General pleas for non-reductionist approaches based on the alleged disorder of the world or on metaphysical claim about its causal structure would be the obverse of general calls for reduction, suffering from the same unfortunate lack of consideration of what actually works in science. Only temporarily qualified arguments that stay clear of metaphysical contentions can usefully bear on discussions of the merit and limits of reductionist approach in science. So I use her argument because the debate over pluralism and monism is more or less the same debate that than the debate over reductionism and non-reductionism. It's a form of the debate. And I think the form of the arguments can be used in the same way. So if we propose a reinterpretation of Mitchell, the interesting thing is that in her article, Roussy mentions that the arguments she's opposing to, so it's arguments by Dupré, Kitcher, these arguments basically all have the same structure. They come from an empirical premise, they then leap to a metaphysical conclusion, and then deduce methodological prescriptions. And so what she questions, obviously, is the move from 1 to 2. In the case of Mitchell, we have exactly this type of arguments. She starts by stating that reductionism failed in some domains, like population biology. She then makes the metaphysical thesis that the world or part of the world is complex, and she uses complexity to advocate for her integrative pluralism with regards to complex systems. My problem with Mitchell's use of complexity is that her prescriptions are very definitive and very strong. And to me, they hold only if her argument is meant to be generally valid. But if it's meant as a generally valid argument, you cannot prove it. It overreaches. But if her argument is temporally qualified, that is, it is epistemic and context dependent, then it is justifiable, but it no longer supports her strong metaphysical or normative conclusion. So whether the argument is too strong to be justified or is it too weak to justify the strong form of pluralism she advocates for. There is a variation of this problem of complexity in philosophy that we can find in Longino. So Roussy actually critiqued Longino, and this is not exactly Roussie's critique of Longino. Mine is about circularity. Basically, I think that in some cases, appeal to complexity to justify pluralism are a hidden way to camouflage a circular argument. Because, for example, in 2001, Longino in The Fate of Knowledge, one of her aims is to explain why scientists employ 4 distinct, partially non-integrable approaches for the study of human behavior. So you have the genetic approach, the neurobiological approach, the social environmental approach, and the development systems approach. And she tried to explain that, why we have to use 4 different approaches. And what she says at the end is that philosophers who advocate strong form of pluralism are claiming that the complexity of natural entities eludes complete representation by any single theoretical or investigative approach. So here she's justifying this form of pluralism on the appeal of complexity. But the problem is that what evidence do we have that the system is metaphysically complex, other than the fact that it requires multiple non-integrable models to be studied? And here the appeal of complexity is a bit problematic because it restates rather than explains the observed plurality of approaches. So here's basically my takeaway on pluralism and metaphysical appeals to complexity. My claim is not that appeals to complexity or metaphysics are always empty or circular. My claim is a bit more modest. It is that in the case of the defense of scientific pluralism, no argument yet has demonstrated that the supposedly metaphysical nature of complexity could warrant strong and definitive claims about the methodology of science. My takeaway on that would be that the viability of pluralism is an empirical and pragmatic matter. It is not an ontological one. And my suggestion would be that pluralism could and should remain temporally and contextually qualified, rather than elevated into a metaphysical doctrine about the nature of complex systems. And for that, of course, I can propose a little perspective if you want to think about it. I have an hypothesis that is that faulty appeals to metaphysical consideration seem to stem from the fact that authors defending it, even though they claim their allegiance to pragmatism, are trying to ground pluralism. That is, to provide it with what Van Frassen called a principle zero, something like a basic statement that would be verifiable in truth. And even the authors of the pluralist stance, so it's Gellert, Longino, and Waters, they propose that pluralism can be a stance, which is a Van Frassen concept, an idea that the philosophical position may not be just a belief about the world, but just a way of acting, which is useful if you want to avoid metaphysics. Even they say that pluralism is not based on metaphysics, but on their respective papers, at least Longino and Waters ground their pluralism on strong metaphysical claims. So my suggestion to avoid this faulty appeal to metaphysics would be to abandon the very idea that pluralism needs grounding, that we need to ground this thesis. And attempts have been made to do that. Azok Chong does it explicitly because he wants to avoid metaphysics. But there are a lot of non-foundationalist friendly approaches to pluralism. One of them is going back to Feyerabend's anarchic pluralism. Van Frassen's concept of stance can help us with that. And recently, Azok Chong has proposed his active normative pluralism, which is exactly a way of trying to avoid metaphysical consideration in pluralism. So my overall thesis is that maybe we might need to stop making pluralism a vicarious thesis about the structure of reality and maybe come back to Feyerabend, which is the idea that pluralism might just be a methodological and normative commitment to certain forms of scientific and social practice. Voilà.
We'll take 5-minute breaks.
Ah, c'est super ça.
Yeah.
Okay, question. Max.
Shut up, Max. Question, comment?
Daniel?
Yes, thank you for the wonderful talk. First of all. And I have actually a minor question about the interpretation of complexity in terms of family resemblance. So can we say that actually the relation is symmetric in the sense that it seems to me that we could define what family resemblance is, given that it's not actually possible to give a definition like that. Could we, let's say, define it in terms of complexity? So it seems to me that it is exactly that we can actually overlap the concept of complexity with families resemblances in the sense of Wittgenstein. What do you think about this stronger interpretation of your simulation?
That's funny. I didn't think about it. Well, I think it's. I think nothing logical prevents it. But I think it just. Well, my take would be that it makes the concept of complexity even larger itself. I don't know if it is what we want or what I want. I don't think Wittgenstein himself conceived family resemblance as something linked to complexity itself. It was more about how things are and the way we use language. Because he just says that if you want to know what language is, just watch. And just by watching and seeing, you can see what language is. So I think it would be anti-Wittgensteinian to define family resemblance in terms of complexity, but it's doable. We will have to see the implications of it. I don't think about them for now. I don't see the pros and cons. But that's an interesting idea to say that. It's symmetric.
Is it possible to find a situation in which we would apply the concept of family resemblances, in which we would not also apply the concept of complexity? That was my question.
Well, it depends upon how you use language. For example, I don't know if you might say that what is a game is complex, but you can say that what is a game is a matter of family resemblance. But I mean, I think the perfect counter-argument logically would be to show that what we call simple things are a family resemblance. Because there you could show that simple things cannot be subsumed under the concept of complexity. If you want to push the argument further, you would have to show that, I think.
Okay, thank you.
I have a question online. So it's Marco Casali. So he says, thank you very much. That's really interesting. I have a question about the cluster of properties. You gave the example of the game, which I found quite convincing. However, I find the properties associated with the notion of complexity, even if we consider only the prototypical one, less clear. Could you say more about that? Thanks a lot.
So the idea is that the different properties of a game are more linked to what a game is than the property of complexity are linked to what complexity is. Well, I don't know if that is a problem for the concept of family resemblance, because, well, I agree with you that the many properties we put under complexity are very different. They're very heterogeneous. I think that I can answer in two ways. the first point would be that there is no threshold of necessary connexity between all the properties of a category. For example, nonlinearity might be really far from, I don't know, memory, and yet both are in the same category of complex systems, just as track and field is very far from the game of chess. The important point is that there is a cluster of intermediary points between them. There is a continuum. I think that's an important condition for something to be a family resemblance. And the second point would be that I think there is the reason that we put all of those properties together may be a pragmatic consideration that contingently some of them are linked together. And that's a question that Plutinsky asked in her paper, is that it is not yet clear how, for example, heterogeneity is linked to nonlinearity or to catastrophic behavior and stuff like this. But scientists have the intuition that it is linked. It would require a tremendous amount of data to show any necessary connection or any highly probable connection amongst all biological systems. But I think the usefulness of family resemblance in that context is just to capture the intuition that maybe there is something to look at between all of these properties. So that would be my response to you, Marco. And thanks for the question. Yes.
Yes, staying again on this family resemblance. So you said that, okay, family resemblance is cool, it's everywhere. But Wittgenstein is talking about ordinary language. And here the question is about science. I was just curious whether there are some additional requirements which have brought the effect of the scientific usage of language rather than ordinary usage. For example, with computers, we laymen use computers without even trying to define what it is, but maybe if you're a scientist who develops new computers, you want to have a theory of computers or something like this.
Yeah, I think and you're right to show that, I think my argument rests on maybe a hidden hypothesis that there is no radical difference between scientific language and ordinary language. This is how I...
This is a strong claim.
Yeah, this is kind of a strong claim. I tried to say, I think one way that we could see about this is Otto Neurath has the concept of Ballungen, which basically is like family resemblance. He says that some of our concepts in science are clusters of both scientific, conventional, highly formalized definitions and concepts, and both elements of ordinary language. And I think for some concepts, it doesn't quite work. For example, when we think about highly theoretical complex, like concepts like neutrino, for example, or elementary particles, these are concepts that are seldom used in ordinary language. But I think that for complexity, it might work really well, because complex is a term that we use in everyday life. It is both a term of ordinary language and of scientific language. So in that case, I would argue that we have good reasons to believe that in this specific case, at least, not in general, there might be a continuum between ordinary language and scientific language that partially warrants my hypothesis. But I agree that in some cases, in more theoretical cases, it might not hold. It will be mine. Okay. But that's a very nice question.
So thank you very much. It was remarkably clear. And of course, I disagree. Because what I like with your argument, it's pretty clear. It's like they do bad things. And even you could have said, no philosopher should ever do a strong methodological prescription on anything in science. Yeah. It's always garbage. We have so many cases. So, but your point was what the passage from empirical to metaphysical is. Therefore, we should abandon the thing and go for stand. And that's the part I don't understand. It's not because Ladyman and Mitchell are bad metaphysicians, that there's not an interesting ontological question about complexity. However, I agree with you. Complexity is not clearly a natural kind. So how will you, from the empirical, get to there? But it's potentially a good case if you limit the system. So it's like, and I will give you an analogy. It's like emergence, ontological emergence, not reduction, because your example was about theoretical reduction. But ontological emergence, it's not easy to show from theories, because if it was, anything non-reductionist would be emergent. But there's some argument that could stand the road if you say, I have some theorem that said that this kind of behavior cannot come from that kind of assumption, something strong, so something almost mathematical, probably not possible to find in cancerology, but very strong. Or right now I'm working with Charles about phase space in biology, and if you need to change the phase space or something like an innovation happened and you cannot reduce to any principle before, it's not a proof of ontological, but it's much stronger than just, there's a lot of theories and there's a lot of models and it seems pretty complicated. Okay, that's a bad metaphysical argument. But I understand that maybe complexity is too vast, as you said. Maybe it's already a too amorphous concept to get to anything in metaphysics. And of course, this is completely independent of the notion of prescription, because you can defend some metaphysical thesis and say, okay, what is the prescription for science, since we don't have the final metaphysical claim about the world? But I thought, I was surprised about how strong was your conclusion.
Yeah, I think I can agree with you on that. There are a lot of cases in which the jump from premise 1 to premise 2 is perfectly,
but justified.
Understandably. But yeah, in fact, my take was on the whole, on the argument taken as a whole, because, as you said, as long as you take a general methodological prescription about science, you are done. And my take is that if they wanted to do that, they would have to have a definite picture of what the world is, and they can't have one, because metaphysics has to be, in some case, informed by scientific theories. It is contingent and so on. So I'm all for contingent metaphysics, and let's analyze the theories and see what there is in the theories, and maybe that could tell us a lot about the world. But of course, I'm against the strong jumps. And I think that Longino and Mitchell do too strong. The leap is too far.
Can I precise? So what Longino and Mitchell do not do, and I had this discussion with Mitchell, not with Longino, is that they don't want to go in the details of what come from the representation means and what the representation is of. Because if you want to say something about the world that is not dependent of the way we represent the world, you have to have a strong argument. You cannot go outside, of course, that's impossible, but you have to say, okay, at least this part of the model seems more robust than this part seems to depend that I use Celsius rather than Fahrenheit. So obviously not important. And in order to do that, you need to have a very good control of the means of representation. And I'm not sure in biology that we are often in that situation, just because of the history of biology. You know, when biology, just think about the formalization of the theory of selection by natural selection. What is the part that depends on us? What is the part that depends on the kind of math we use? What is the part that depends on the kind of way we represent species?
Yeah, the argument may be that the requirements for robustness that we need to make those arguments can't be found in biology.
Could be.
But what we should...
But that would be a metaphysical claim about biology.
And what we should be careful about is that we may be tempted to ground this claim on complexity. And that's exactly where I do not want to go, is that I can see that some philosophers will say, well, that biology is messy, and it's messy because it's complex, and therefore we need multiple models and and then it just like,
Okay, fair enough.
that was my initial intuition.
Thank you.
Yes.
Yeah, I'm just curious about this book by Leidemann and Wester. What's they say in the end? It's like they say it's homeostatic property cluster. They say it's just cluster.
That's very strange. And I read a review of the book, and the reviewer is frustrated as well, because the book kind of presents itself as a comprehensive review of measures of complexity and measures of complexity and stuff. And the reviewer says that it's more an opinionated introduction to the topic. And I think he's true, he is right, because the first part of the book for me is very nice, because they take all these different concepts of complexity and they review all the mathematical measures of complexity, which is really nice, because when you, for example, if you look at Mitchell or Longino, they don't really study what does it mean to study complexity, what are the equations basically. And Leidemann and Weisner do that. But the philosophical discussion of the book is, the book is very small, it's like 200 pages, and the philosophical part of it is only 20 pages. And they basically fight with straw man for all the books, because they said, well, basically there is three positions about complexity. Either you're nihilist, you think that it does not exist, either you're a pragmatist, that is, you are agnostic, or you are a metaphysical realist. Nihilism and pragmatism only spend one page of the book, and the 19 remaining pages are about realism. I don't think they position themselves explicitly on homeostatic property clusters. I think it is what they have in their head. Because obviously they can't defend the essential conception of natural kinds. So I don't know, maybe you've read it as well.
No, but it's always straw man with James.
With James. Yes, it's more like, well, we want to be realist, so what we can tell.
So since nothing other than realism is acceptable.
Yeah.
Yeah.
So, but it will be interesting to see the homeostatic property.
Yeah, this one will be this homeostatic thing.
Yeah.
Complexity, like concepts and entities.
And it would be like a metaphysical reinterpretation of family resemblance. It would basically mean that, well, there is family resemblance and there is a mechanism that links all of this stuff. Basically. And you also have the concept of stable property cluster. So it's like property cluster, but without the homeostatic mechanism. So I've read a bit about that.
Yeah.
My only concern with that is that, well, that it's not really what we want a natural kind to be, I don't think. Because for me, the good stuff for me about a natural kind is that once you say that something is gold, you can extract hundreds of properties because you know it's gold. If you say, well, it's a natural kind, but it's only probabilistically tied and sometimes it's contingent, and well, then is it really what we want to be? Maybe we don't need everything to be natural kinds, but
it's another stable property.
Yeah.
Because it's just
well, it's
it's like family resemblance in a way that when you want to say something, but you can't say anything.
Yeah, so you add the metaphysical thing to it. It's like, well, it's a natural kind anyway.
But just a comment, maybe even if it's very difficult to see how it is a natural kind, I think it's important for the people to argue for that, because that means it will be a discipline separated of biology, and there will be complexity science like they try. So there's also a organization of research behind that claim. If you study a natural kind, whatever it is, because I have no idea what it is, whatever it is, you can justify there could be a university discipline, specific things. So that's sometimes important. At least for social kind, that was the case. For biology, to say it's not the same kind as the other discipline, to justify also the organization of research. So it's not just metaphysics in the cloud, it's also research politics. but it seems very difficult to make a natural kind with this phenomenon.
Questions? I have one, but it's a very specific and just a detailed point.
Go.
I'm not that familiar about Cheng's view, so what's the point of his active normative pluralism, except that he doesn't want to do physical stuff?
Well, he has a funny way of saying it. He writes really funny books, I think, in Google. But he says that his thesis is that if a science is monist, that means science uses reductive methods and stuff, that it is probably a bad thing. That's his general idea. His idea is just that we should look at what are the benefits of employing pluralism, and like the concrete benefits on research outputs, on socially redistributing the resources of research, which are very strong, concrete arguments. And he actually responds to Michel, Angino and stuff. He said that, well, he has the intuition that the world is complex. Of course, everyone has the intuition that things are messy and stuff, but he does not want to ground his thesis on that. He thinks there are better ways to be a pluralist than to argue about the structure of the world. And that will be my argument as well, is that we have enough elements, we have enough stuff, just by analyzing representation and analyzing what we want to do with science, what we need to do about science, and what is not great in science. Just by looking at that, maybe we have enough arguments to already sketch a coherent position, and then after maybe we will look at metaphysical foundation of this. But maybe we need to start simple. Yes.
Just my own thing. So you know that in physics, for example, there are techniques to measure complexity, like based on entropy or Kolmogorov techniques and like that. So you basically would say that these approaches do not really exhaust what complexity is, maybe just in physics, and that we need a much broader approach like the one based on family resemblances to grasp this concept. So what does your perspective imply concerning these, I'd say, numerical techniques to provide a measurement of complexity, limited to physics?
Well, as you know, I'm not an expert in physics, and my intuition will be that if we are to look at objective ways of measuring complexity, yes, of course, the best candidate for that would maybe be physics, because of what we spoke about with Alexandre, meaning the robustness of the phenomena, when we can quantify everything and we can mathematize everything, and in what we call complex system biology, researchers are really quick to use those physical models that I don't really understand yet, but they are really trying to bridge the gap between biology and physics, and it's a very interdisciplinary field. It's very interesting what they are trying to do. For me, the main problem is just that there are things in biology that are not modeled in physics, and so you will have to have a form of bridge law or a bridge principle to say that, for example, what we call memory or adaptive behavior is just a form or can be mathematized as like a retraction or a nonlinear equation of stuff. If we can do that, then maybe physics has the answer to quantifying complexity. And the best bet we have right now to understand what complexity is to apply mathematical models, some of them coming from physics.
Yeah. But yeah, just another question. Do Lediman and Weisner focus on some specific science? Do they focus on biology? On
No, they look everywhere, which is the interesting stuff for me. But as I said, what we call complex systems, there are really paradigmatic cases of complex systems. So the climate is one. In physics, I don't know what are the paradigmatic cases of complex systems.
Then you consider.
But you might have stuff, so to example, like chaotic behaviors, triple pendulums, and things like that. But they do not exhaust all the possible complex systems of physics. I will have to check that.
Yeah, sure. No, I was just curious what their main focus was in terms of.
It's everything.
Thank you.
Another question online. I think it's still Marco. A provocative question. The homeostatic property cluster is also frequently used in the philosophy of psychiatry, particularly in debates about the classification of psychiatric disorders. However, in the case of complexity, classification is not the issue. Could we just specify the properties of a phenomenon on a case-by-case basis instead of using the umbrella notion of complexity? It is not an important question. Between parentheses.
Yes, it's funny because I had a discussion with a friend, I think it was yesterday, and she said, well, basically you can replace complexity with, for example, nonlinearity, heterogeneity, and stuff like that. I think that two answers. First, it might be possible in principle, but then I mean, we just need to look at like the debates between Carnap and Neurath on whether or not we should go back to protocol statement. That's basically the idea. Or any form of protocol statements, not necessarily like phenomenological statement, but we could replace all the words of ordinary language by clear definitions of what we mean. It is possible, but I don't think science will be the same. I don't think it would be science like we think it is right now. And the second idea is that, as I said, I think naming something as complex may also mean that we have some intuitions about it. For example, intuitions about how we can deal with it, how we can treat it, and where we can look. Because, for example, if you say that cancer is complex, you put cancer in a category with a lot of things, like the climate, double pendulums, ecosystems, stuff like that. And it might be a way to say, when you say something is complex, it might be a way to say, well, let's look at those other systems that we call complex, and let's compare to those systems. And it's something that has been done regularly in biology, for example, to say, well, cancer is complex, ecosystems are complex. Let's see the link between ecosystems and cancer. There are feedbacks in climate. There are feedbacks in biological population. Let's see the difference. So the good thing about family resemblance and the fact that we use a not very clearly defined term for a broad category is that we can play this game of family resemblance, and it opens way of conceiving objects that are very far from each other and that are in complete different disciplines. It might help to do interdisciplinary work as a problem of scientific practice. And as you can see, for example, this new science from 20 years that is complexity science, it is now the real science. It is one of the most interdisciplinary science you can find. Seminars about complex science, about complex systems, try to regroup physicists, mathematicians, sociologists, biologists. And I think it's a very interesting thing that a ill-defined word like complexity can do such work, actually. So that's not an unimportant question. That's a very nice question.
He said, I do agree.
Oh, thank you, Marco.
Just to follow up or a similar question, it's okay. There is this idea that okay, so complexity, maybe we should just in some cases say non-linearity or robustness or having many components or having many types of components. Can you ground something philosophical in the sense of philosophy, general philosophy of science, based on these things? Maybe just complexity is too not good enough. But if we just say heterogeneous, if we just employ heterogeneity, maybe can we ground something like pluralism on heterogeneity purely? Or?
Well, you could do that, but it will be way less broad than to qualify it on complexity. But that's exactly my take. I think there is at least two ways of interpreting all the stuff about complexity. Either you have like a logical empiricist intuition, and you say that, well, this term is ill-defined. Maybe we can replace all the iteration of those terms by more precise one. And then we could ground arguments, very specific yet powerful arguments on this concept. Or either you take a more liberal, pragmatist approach and you say, well, just don't ground stuff. Let's stop grounding stuff on stuff. That would be my approach, which I think makes for less powerful arguments. And I think reading Wittgenstein again, he would say, I mean, it doesn't prevent him from speaking about language and grounding argument about language, the fact that language is not is a family resemblance. It's exactly this point. His point is that, and I think it's a important point. Of course, it's Wittgenstein, so he makes very big, broad claims about the world. But at the moment, he said that it's basically the one big flaw of philosophy is that we are trying to ground stuff by giving essential definitions. And he traces this back to Plato, because if you look at the Plato's dialogue, it's always the same thing: is that what is the fness of f? What is the goodness of good? What makes good good? Well, it's a set of properties, and we cannot understand what is goodness if we do not give such a proposition. Well, Wittgenstein said that maybe we don't need to have such strong claims. We can be more plastic. The fact that we do not have those definitions does not impede us from doing philosophy and from arguing.
Yeah, but with the sort of methodological claims made by these pluralist philosophers, will these claims become stronger if they replace complexity and just stuff saying, okay, world is not complex, but world is heterogeneous, or I don't know.
Well,
something like this.
I think it would have to be very, it's my take, but it would have to be really conditional arguments. Things like, if we want to do X in a particular context, based on XXX models and XXX theoretical manipulations, then we have good reason to think that something is heterogeneous in that sense. And then if you want to do this, we could do that. I think that would be of course, it's not Plato, it's not Aristotle. It's a very short philosophy, and to some people it might be depressing. But I think that it's a very healthy way to communicate with other philosophers and other scientists. It's to say that, well, you have this problem, and I can help about this problem, but we have to be clear about what are the data of the problem and what exactly we want to do with science. That will be my take, to make the problem smaller.
I have another question.
I have other two, but yeah. Right. Victoria present.
It's my question.
Okay, so you, in your answer to Azad, clearly you do not think it's a stance.
Pluralism?
Yeah.
Oh, that's funny.
Because at least because a stance, according to Van Frazen or LNBB, that renewed the notion of a stance is something that you cannot prove and you will not able to prove, like the realist stance, whatever James says. but it is a project, so it will orient everything you say, and you will develop the stance as far as you can and compare it to other stances. And so how do you see pluralism to be a stance, to be something like, okay, we will develop, because it seems that they have the answer. They'll go, the world is complicated. I think simplicity, reductionism is a stance. You say, I will try to prove to everybody that, but if you start with the world is complicated, what will you do to how it will orient research, for example, or?
Well, I think there's two parts to the answer. The first one, the more scientific one, would be to promote and to do interdisciplinary stuff.
Okay.
And this is it. I mean, there is an important distinction here to make, because, of course, interdisciplinarity is a buzzword. It's a nice word that you put in a financing project, and that's good. But if you look at like how science is done, it's very interesting that interdisciplinarity has that there is a lot to be done about interdisciplinarity, because there is what scientists write and there is what they do. And when you look at what they do, like in the lab, well, it's the opposite of interdisciplinarity. They're just doing their job, and then they say in the papers, well, we have to be interdisciplinary, we have to look elsewhere. But I think a strong pluralist project would be to coordinate those efforts, to make seminars, make stuff, make a fellowship, stuff like this. The other part of it has actually been proposed by Azok Chang, and I think it's a really interesting thing. I don't know, I think he calls it complementary science. But his idea is to look at scientific projects that have been abandoned. And he does that really well with the theory of phlogistic, where he shows for hundreds of pages that basically we have abandoned the theory of phlogistic too soon. And I think it's a very nice way to be pluralist. It's a way of saying, well, sometimes we abandon theories too quick, and we do not abandon theories because they are false, but we abandon them because we have other alternatives, and contingencies make that we go to these theories without completely disproving the others. And he says that maybe one role for philosophy is to really study those old theories that have been abandoned, because, well, we only have that to do. We are not constrained by the need to produce empirical data and stuff like this. We can go and look back at old manuscripts from 2,000 years ago and say, well, Aristotle had a good point about this.
That's pluralist. That's
Yeah,
pluralist.
I think that would be pluralist.
Okay.
I think.
Okay. So you said two things. It's not the same thing, and I don't see the connection. So you said, okay, if I'm pluralist, I will promote interdisciplinary science. Of course, today with transdisciplinarity, it's complicated. And in any way, it's always the same problem, even if they talk very complicated. What is the criteria of good production a discipline gives? What is the good criteria of a good paper in, I don't know, the mix between sociology and quantum physics? Who the fuck knows? Yeah. Okay, so what if you say pluralism could be a stance? So do you claim that we will have to develop some prescriptions of this interdisciplinary science? This is good interdisciplinary science, this is crap. Okay, because often, especially, it's not easy to have laboratory, and experiment. So that's my first question on the first part. And I don't understand the direct connection that Azok Chang seems to see, that that's an opportunity if you are pluralist to go to explore some avenue that were not taken in science.
Both are links, actually, I think. So he argues, and I think I agree with him, that pluralism is not a thesis or a stance, but I think he considers it as a thesis. It's not a thesis about criterions of validity in science. It's a thesis about the means of doing science.
Okay.
So he has a word for it. He says that pluralism is not about who is at the table. It's about, do we need many people at the table? It might be a bit unsatisfying for some people. And I think he has a second argument about this, and it is an argument that he draws from Feyerabend, actually, is that whether or not and I think it's a strong argument, and there has to be discussion about this, whether or not a product of research is a good product or a bad product, it is useful to have those products. Feyerabend draws this, he makes a very strange argument for Feyerabend. Feyerabend proposed a very formal argument from Karl Popper theory of refutation. He says that if we want to have propositions of refutation, then we should have as much theories as we could have, because we statistically increases the robustness of our theories. And so that's why Feyerabend, for example, defended astrology and stuff like that. He said that, well, when you defend astrology, you actually make a stronger case for astronomy, for example. So the link between Feyerabend and other chunk like that, is to say that when we look back on abandoned scientific paradigms, basically two stuff can happen for Chang. Either you discover that we missed something and that there is actually a cool idea in something we abandoned, or there is nothing more interesting or absolutely devastating in that other case, and then you have just make the actual case stronger. That would be his argument between the two.
But isn't it just feminist philosophy of science?
It might be linked. Chang does not make the case for feminism.
Yeah, but that's close to Longinot and all these.
Yeah.
It's just that maybe Chang does not quote, as usual among male philosopher.
Yeah.
Feminists.
Something about like.
But that's also Feyerabend, is the idea that there's no such thing as any criteria, ultimately, so let's try everything.
Yeah, and we will see after.
That's pretty Longinot.
Yeah, I think it might be a hard thesis.
Sadrian Harding, or
Yeah, it might be a hard thing to speak to scientists about this.
yes.
And I'm still finding ways to argue it in their language.
Okay, thank you.
That's that.
Yeah, so again on this idea of pluralism as a stance. So as Alexandre made quite a valid point that the thing about reductionism, one is whatsoever, is that it gives a clear sort of thing what to do.
Yeah.
Like you should reduce, go on. Pluralism seems not to be able to do this as straightforward way, and I was thinking whether pluralism can be just a negative thing, saying like, there was this quote I remember from Stephanie Roussy, I think, that look, these anti-reductionists who always call for anti-reductionists, they're no better than reductionists.
Mm-hmm.
So this implies that these reductionists who also metaphysically charge their claims about reductionism, it's the same fallacy.
Yeah.
So can pluralism have just this very negative role of cutting all these metaphysical claims of strong monist reductionism, blah, 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 and that's it, without anything positive?
Well, I think that historically it has been this for a lot of time.
Okay.
And it has done, I think, wonderful work in putting water in the wine of reductionists by saying that, well, maybe some things aren't reducible or something. But there has been critics, especially by Stephanie Roussy, that maybe pluralism can be more than a negative stance. Especially because when you read Pluralist, for example, when you read the Pluralist Manifesto in 2006 by Keller, Longinot and stuff, the monist position that they are opposing themselves to actually does not exist. It's a straw man. Like, even if you believe in the theory of the whole, or even if you believe in a strong form of unity of science, it's the paper by Putnam and Oppenheim, the old paper. Even this hard paper does not defend the sort of monism that Keller and Longinot speak about. So they attack, that's the problem when you have a negative position, is that if your opponents retract the negative position, your position does not exist anymore. And that's actually a problem I spoke about with Stephanie Roussy and stuff. And there has been a proposition and in the literature to propose a more positive account of pluralism, and it's exactly what Mitchell speaks about. She says that, well, the project of pluralism now is scientific integration. How do we integrate results and stuff like this? The problem I have with that, and it is in the title of my thesis, so I hope that in 3 years I will be able to give you an answer. I will not. Is that since Mitchell, so since the book she made about integrative pluralism in 2003, almost every article on pluralism ends with a programmatic conclusion that, well, we need to look seriously at integration, and now pluralism, now that it's a full-blown thesis and that everyone agrees that the world is complicated and stuff, we need to see how to integrate. And all articles end with that conclusion. But yet, even Mitchell's account of integration is largely understudied because she just proposed it.
And it's mostly pragmatic consideration, isn't
Yes.
it?
So my take is that if we want to make positive stuff out of pluralism, we have to check integration, because for me, the promises of pluralism largely dwells on the issue of integration. If you said that we need a plurality of perspective and stuff, yeah, that's good, but at the end we want knowledge and we want to act upon this knowledge. So if just everyone speak in his own room, we won't have any way to transfer that knowledge into a practical action. And that's also why I study cancerology, because in cancerology you have a very pragmatic problem, is that first you have to treat patient, and that a plurality of theories will be linked to a plurality of treatments, but a single patient cannot bear more than, I mean, you cannot put 20 treatments in the patient, he will just die. So there has been an hypothesis by the pluralist, basically a hidden hypothesis, that there is a direct link between explanation, prediction, and action, which I think is not evident, and especially in the case of biomedical science. So yeah,
Okay.
positive account of pluralism is a real problem.
Because what I was thinking when I was asking this question was some people, for example, in the Cambridge Theoretical Biology Club were saying, when we were looking, then they were saying explicitly something like, all our experimental science is mechanicist, so we are doing mechanicist biology, but we don't do the final conclusion that life is mechanism. And this is why it's so important to oppose mechanicist blah blah blah, this mechanicist vitalist debate of the 20th century. So
Yeah.
in the sense they were saying that when it comes to actual science and actual sort of experiments, we will do in the end mechanicistic experiments, because this is the only thing we can do, and this is the only sort of framework which guides us, even though we always have this sort of guarding thing which only negatively cuts off the
Yeah, but I think it's that Alexandre made the remark about this. I think that reductionism and mechanism can really be understood as stances. Like when you're a mechanistic scientist, you don't assume that everything is a mechanism. And Van Frassen speaks about this very nicely about materialism. He says that materialism is not. When you say that a scientist is materialist, you don't suppose that she has a strong belief in the proposition that everything is made of matter. She's just that if she has a scientific problem, she will look at matter. She will not look at spiritual forces of God. And I think in the same manner, when you speak to scientists about, well, there is a problem with cancer and people are dying and stuff, the first question they're going to ask is, what is the mechanism? Because it's a stance, it's a way of looking at the world. And if you have all the stances or the propositions, you have to show that your stance is better suited than theirs. I think it boils down to this. And that's the problem with, I think, philosophical opposition to mechanism and reductionism, is that they are not on the same plan. You can be anti-reductionist in your room. And when you speak with scientists, most of them will be anti-reductionist. They agree that, well, the world is complicated and the whole is the sum of it's more than the sum of its part and all that stuff. But in the end, they have to make experimentation because they have to treat people and they have to produce scientific results. And for now, that's the best way we have to produce results.
But I'm sorry. Here, there's an interesting analogy in another science. It's the philosophy of mind, the philosophy of consciousness, because it was clearly, when you talk to most neuroscientists, they were really strongly mechanistic. They don't all agree about what is the mechanism, but they are strongly mechanism. And the people coming from complexity science, they say, no, it has nothing to do with mechanism. It's a dynamical system, blah, blah, blah. And for a long time, these community of researchers were not exchanging at all until after 3 decades, we still don't know anything about the mechanism of consciousness. And now maybe there's more communication between the two community. And maybe at the end, consciousness has and maybe consciousness has nothing to do with the dynamical system or mechanism. I don't know. I don't know where the research. But here you see how it took a long time, and I don't see it's more your field, but molecular biology is still the dominant paradigm of biology. So who is pluralist for real,
Yeah.
Everybody's mechanistic no, I don't know. No, not at the level maybe of natural selection or animal behavior, but when they look at cancer, they look at cells and it's a mechanism. It's maybe a complicated mechanism.
Well, I think there is you can be mechanistic and pluralist. That's, I think, the official position of most scientists. I think my thing is that, as I said, while everyone in science, when you speak about them, they're all like, well, of course, it's very complex, a lot of mechanism, sociology, blah, 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 blah.
But it's all mechanism.
Yeah, what they study, what they actually study in the lab is that they go back to mechanism, and that when they produce scientific results, they always produce it, they think most of the time they produce it in a monistic kind of way by saying, well, there is a theory, it is wrong, mine is better.
Okay, so let me reframe, because your case study is cancerology.
Yeah.
In what way it is now pluralist? Or are they just all looking at mechanism?
Well, I think it's a mix of both. It might be more pluralistic in the sense that there is now more interdisciplinary research in cancerology, especially with regards to mathematization of cancerology and ecological approach to cancerology and stuff like that. This is actually kind of new in cancerology, which is very surprising when you come from evolutionary biology like me, stuff like that. But at the same time, when you look at practices, they do not align with what is written in papers.
Okay.
And that's my concern. It's
So it's still not
yeah, it's very programmatic.
yeah, it's still not the good case of pluralism science.
Yeah, my guess is not to show that.
On that way.
Yeah, my guess is not to show that cancer is pluralistic, is to show how we can make it more pluralistic.
Okay.
Or what would be the benefit of making it pluralistic.
Okay. Fair enough.
Louis, tu voulais dire un truc, non? Ah, je crois. Ah, j'ai cru que tu avais levé la main. Ah.
Non, désolé.
Tu rayonnes.
No one has a question, I have one.
Oui.
So I read something about physifying the notion of family resemblance by Wittgenstein. I don't know if you know a bit about fuzzy logic.
Physiology?
Fuzzy logic.
Ah, fuzzy logic. Yeah, okay. Just a bit.
Okay. So my question was, is it relevant to fuzzify complexity? So, okay. So yeah, the idea of fuzzy is you have those paradigmatic cases, and there are cases that are not completely like complex, but less complex than other. There's a spectrum.
Yep.
Is it relevant for complexity?
I think it would be. I'm not fluent in fuzzy logic.
And I would even like to complete, because it's exactly what it looked like when I was talking to
Yes.
so I wasn't sure when you spoke about family resemblance. Some are more important than others.
Yes.
It's basically fuzzy logic, and
Yes.
I'll go for it too. Then you talked about context.
Mm.
So it's one of the answers to like one of the logic that could be used in logic. So one, like, it could be replaced maybe not replace, but
Interpret family resemblance in terms of fuzzy logic?
Yeah, or even were you talking about complexity in general, or will it be one aspect of it?
I don't know anything about complexity, so I don't.
Well, I think an interesting stuff, but as I said, I do not know the formal language of fuzzy logic, but it would be, I think we can do like, in some cases, for example, you take a case study and you try to see the proximity between different terms, and I think it might be different among disciplines. There might be, well, as I said earlier, in physics, there are stuff that are not there. For example, Darwinian adaptation. There's no Darwinian adaptation, but maybe you could maybe formalize the proximity between, for example, heterogeneity and numerosity. I think, and I don't know if fuzzy logics can do that. Yes.
So fuzzy logic can completely formalize the proximity, but there's also this idea, like we can say stuff like climate is more complex than thing. And is this comparative thing interesting for complexity?
I think yes, because there are debates in the literature. I think, for example, Plutinsky says that complexity is a matter of degree.
Okay.
I think it's a strong claim, and for me, it's kind of a problematic claim. Not that I don't agree with her. I have this intuition as well. But when you say that something is a matter of degree, it's an easy way out to do not give necessarily insufficient condition. But you face a lot of problems, like problems of where do you put the threshold? If everything is complex, nothing is complex, things like that. But I think that there is a strong intuition on the part of scientists that if you can quantify complexity, then you could show that some things are more complex than others. And I think that's a very good idea. Yes.
But if I can add, there's a tension here with what you said at the beginning, that there's a continuity between scientific language and natural language. Because Wittgenstein would say that fuzzy logic would only work in an already formalized language with fuzzy concept, because natural language is so complex and so plural. Blah. It's why we have this bizarre family resemblance that cannot be defined really. So the fact that Alexandre, if I may, is saying, yeah, I see a continuity with natural language will limit the capacity of fuzzy logic. However, if you say that scientific language is a much more controlled language where everything is most of the time defined by definition, explicit, there could be fuzzy concepts that have a use in science and they are already in the way of, their border will always be fuzzy, but because of their nature.
So that could be a fun way to test the hypothesis.
Why not? Why not?
Between quantified language. If fuzzy logic can successfully apply, then that means that.
It means fuzzy logic could apply anyway for other reasons, but Wittgenstein would say the problem family resemblance of fuzzy logic is not the same at all, because fuzzy logic presume already a formalization of language. Minimum. You have a fuzzy frontier, but there's frontiers. Between games, it's just a graph with arrows and vague resemblance, whatever that means. Resemblance, what does it mean? Nothing. Everything is, Goodman has a theorem about, the resemblance, that everything is resemblant to everything, if you just look for the right criteria.
But then is it not that, like, everything that describes I'm not sure of the word, sorry in advance, but everything you say about it is fuzzy, but some stuff are, some other are not, but the way, so you used the computer earlier, or just speak about the table, you know what it is, the table in itself, but you could not define it for sure. It could be only 3 feet, it could be not that, it could be that you cannot put something on it. Could it not be that then everything is, every definition of something or every concept is fuzzy, could be defined in a fuzzy way, but it does not mean that everything is a real element in itself too. There is.
Yeah. No, but is it a question to me? It's just that for Wittgenstein, okay, for Wittgenstein, I don't know for Wittgenstein, language is opaque as biology. Okay, it's a thing that works and we know how to do it, but there's nothing that can be formalized there like biology. He was thinking, obviously, complexity before the letter. So it doesn't mean that it's arbitrary, but it's just, yeah, you know that it's a game, but if I push you, but you know, you are very efficient in ordinary life to use efficiently this word, but you will not be able to explain to me what it is, except by family resemblance. I think fuzzy logic is more optimistic. It's to say, okay, we have fuzzy border between concept, but at least there's border where we can say things like baldness or whatever. If it's really family language, as he was claiming in the argument, it's much more difficult to capture. It's just a thing that is, you know how to use it, but you learn by using. And we cannot define it, which is, science. You always need definition or you're lost.
Well, like what your statement could say is that when you apply fuzzy logic, you actually draw a boundary.
Or even fuzzy, yeah. Even fuzzy, you're producing a boundary.
So it's like the Olympic Games stuff I said. You have drawn the boundaries and then you explain things in them.
And there it was more, you use the context to explain it.
Yeah,
and to draw this.
But it might be the case when you use fuzzy logics as well. Right?
It's not defined by context. Answering by, depending on the context, you have a different truth value. It's going to be contextualism, actually. And fuzzy logic, I would say it's more you put really your truth number, and then at one point you indeed, somehow it could be linked with superlationism and superlationism, and you could say at that point where it's no everywhere, it's really a no.
But with game, you will never have that.
Don't you? You don't have a stop to the family.
Fuzzy logic can be contextualist
As well? Okay.
Yeah. Voilà. So maybe that's more complicated.
So within between could be, and then you define your fuzziness regarding the context?
Yeah, you define your stuff that you want to define.
Like a domain or something.
Sorry?
A domain?
Yeah, you define your domain based on, so different society may have different domain of.
But the case, the case of the Olympic Committee, that's the interesting one, because the fact that they say this is not a game because of X, Y, Z is not changing the notion of game in natural languages. It's just saying we put the frontier here, but obviously they do not claim chess is not a game in general language.
They're not talking about games, but they're talking about Olympic Games.
Yeah, but Alexandre presented it without disqualification to show how it was a more interesting case. Because if they say Olympic Games, okay, they have a definition, and it's not family resemblance.
Sorry, but maybe it was too much of the question. You spoke about model and you oppose it to the system, if I'm not mistaken.
I spoke about what?
Models.
Models.
Models. Which category or which type of model are you talking about? Or is it model, or how would you precise what is a model?
It's very complicated. What is a model?
Yeah.
It's like what is a model is very complex.
To ask you what is a model,
Well, for example, if you want to study like a population with preys and predators, you use a Lotka-Volterra differential equation. It's like just two equations. Well, in that case, so these equations are nonlinear, and so in some cases, people are saying, well, it's complex because the system itself is nonlinear. And in some cases, they're saying the equations are complex because they are non-linear. And so my concern was, if we wanted like a very strong definition of complexity, like an essential definition, we would have a problem, because complexity does not always apply to the same object. Sometimes we speak about complexity because we assume that a particular object is complex, and sometimes we say that something is complex because the mathematical models are complex in a particular way. And so for me, that's a big argument against, for example, trying to give definition of complexity, is that complexity can be ascribed to many, many things. That's, for me, a problem of complexity as well, is that it's not really clear in the literature.
But, sorry, only adding one to the theory. Okay. Then those complexities, this complexity that you find in models, is that complexity that is already the thing that the model is trying to describe, and that's the more complex, the more correct it is.
That's Mitchell's assumption, but it's a very strong metaphysical assumption. Is that mathematical complexity is it simply reflects biological complexity. That's her claim, and that's the metaphysical leap she makes.
Okay. Thank you again for speaking.